In the remote sands of northern Mali, a young boy named Ibrahima Traoré spent his days staring at the endless golden dunes, wondering why the blazing sun that scorched his village daily couldn't also power it. Born into a modest family of nomadic Tuaregs, Ibrahima's earliest memories included watching his mother cook over smoky fires and his father navigating the desert with nothing but intuition and the stars. School was a luxury many in his region could not afford, but Ibrahima's curiosity set him apart early on, and a visiting NGO volunteer noticed his brilliance and helped him get a scholarship to attend secondary school in Bamako. From there, he excelled rapidly in the sciences, eventually earning a place at the University of Ouagadougou, where he pursued physics and materials engineering. Even while surrounded by textbooks and laboratories, his heart remained in the desert, pulsing with the same question: why couldn't sand be more than just a burden in the wind? He began to study the properties of quartz-rich sand, particularly the silica content, which, under certain conditions, could be used to form conductive surfaces when treated properly. Ibrahima poured years of his life into trial and error, working out of a humble workshop built from scrap in the outskirts of Bamako, repurposing discarded solar panels and baking trays to test his theories. It was there, under a corrugated tin roof and the searing Malian sun, that he finally created his first prototype, a solar panel whose primary material was processed desert sand. Unlike traditional panels that relied on imported silicon wafers and expensive refining processes, Ibrahima's panel used sand thermally and chemically treated in a low-cost, eco-friendly process that could be replicated in rural areas. Word of his innovation spread quietly at first, mostly among local engineers and renewable energy enthusiasts who were stunned by the panel's performance in off-grid conditions. But soon, international researchers from Germany and South Korea took notice, inviting him to conferences where he presented his methods and field-tested results. He dubbed his innovation the Desertec Cell, a modular, scalable, and sand-based solar panel that performed nearly as well as commercial models at a fraction of the cost. The key to his process was a step-by-step refinement system that began with finely sieving desert sand to isolate high-purity silica particles. These particles were then subjected to a unique heat treatment cycle using solar concentrators, which Ibrahima also constructed from polished scrap metals and broken mirrors. Once heated to the right temperature, the silica began to restructure at the molecular level, and when cooled under controlled conditions, the resulting material formed a semiconductive glass. He coated this material with a conductive organic compound derived from local plants and minerals, creating a surface that could absorb and channel solar radiation into usable electricity. The entire process was designed to be simple enough for local workshops to replicate, using commonly available tools and materials. What made this breakthrough even more significant was its ecological footprint, or lack thereof. No toxic chemicals, no carbon-heavy transport, and minimal waste. Ibrahima began training local technicians and youth in how to build Desertec cells, setting up pilot programs in small villages across Mali, Burkina Faso, and Niger. In the village of Timbuktu, for the first time in years, the local health center was able to refrigerate vaccines and run basic diagnostic equipment thanks to a Desertec-powered system. Schools that once closed at dusk were now running evening literacy programs, with LED lights fed by panels mounted on rooftops made of mud and thatch. Women, long burdened with fetching wood for fuel, found relief as clean energy allowed them to cook using induction stoves powered by Ibrahima's panels. Small businesses, including tailors, barbers, and grain millers, extended their hours and grew their customer base, revitalizing local economies. The impact was undeniable, yet the road ahead remained riddled with obstacles. Scaling up production required more than just community effort. It needed capital, political will, and industrial partnerships. Despite his success, Ibrahima struggled to secure substantial investment from government bodies, more interested in imported solutions than homegrown ones. Still, he pressed on, driven not by profit, but by a vision of energy equity across the Sahel and beyond. He collaborated with regional universities, open-source research labs, and global think tanks to refine his process and make it even more accessible. With support from a European nonprofit, he established the first Desertec workshop hub in Gao, a center for R&D, training, and solar innovation using desert sand. The hub attracted young minds from across West Africa, turning into a cradle for green engineering grounded in indigenous knowledge and raw local materials. Ibrahima's goal was to create a movement, not just a product, a decentralized network of energy creators empowered to change their own futures. As the energy crisis deepened globally, more eyes turned to Africa not just as a market, but as a wellspring of solutions. In South Africa, experimental integrations of Desertec panels began appearing in informal settlements around Johannesburg, providing nighttime lighting and phone charging. In Egypt, researchers from Alexandria University began exploring the integration of desert glass tech into existing solar farms to increase yield and cut costs. International organizations like the UNDP and IRENA started citing Ibrahima's work in their reports, flagging it as a viable model for decentralized, sustainable energy infrastructure. Yet challenges remained, especially in ensuring the quality control of panels built far from centralized labs. Ibrahima tackled this by developing a mobile app that used image recognition and sensors to diagnose production flaws in panels on site. He also initiated a certification program for local builders, ensuring that Desertec cells met baseline performance and safety standards. Despite these gains, logistical hurdles persisted. Transporting raw sand, though plentiful, was hampered by poor road infrastructure and regional instability. Then came a breakthrough. Researchers at the Gao Hub discovered a way to process sand in situ, using portable concentrator ovens that eliminated the need for transport altogether. This meant entire villages could turn their surrounding sandscapes into sources of light, health, and opportunity. The social implications were enormous. Access to energy increased literacy, improved maternal health, and reduced environmental degradation from wood burning. It also had a psychological effect. Communities saw themselves not as victims of climate change, but as protagonists of a renewable revolution. Ibrahima, once a boy lost in the dunes, now found himself traveling to Geneva, Nairobi, and Tokyo, spreading the word about the silent power hidden beneath our feet. Yet he never lost touch with the people and land that inspired it all. He kept returning to Mali, walking the same desert paths with his solar concentrators and teaching kits. Each time he saw a light flick on in a remote village, he was reminded why he began this journey. He knew the work was far from over, but the path was now lit, with sand turned to power and belief turned to reality. The Gao Workshop Hub buzzed with renewed energy as more regional governments began sending delegations to observe Ibrahima's sand-to-solar innovation firsthand. With youth from Senegal, Chad, Ghana, and even as far as Eritrea now attending seasonal boot camps, the hub had evolved into a Pan-African center for sustainable energy education. Ibrahima introduced what he called the Desert Scholar Fellowship, a fully funded, skills-based program aimed at training 1,000 renewable energy builders by the end of the decade. Each fellow would return to their home region with a starter kit containing the tools, materials, and open-source blueprints to begin their own solar workshops. This model not only decentralized energy production, but also seeded microeconomies where knowledge became the most valuable currency. In Burkina Faso's Sahel Reserve, one such fellow, Amina Ouattara, used her training to equip a nomadic Fulani community with mobile solar carts made from converted donkey trailers. These carts, powered by Desertec cells, became mobile power stations for cattle vaccination fridges, LED lights, and water purifiers. In Kenya, students at a rural polytechnic began producing small Desertec panels for use in irrigation timers and greenhouse climate controllers. Word continued to spread online and in local radio programs, drawing attention from both allies and skeptics. Some critics questioned the long-term durability of sand-based panels, pointing to traditional photovoltaic lifespans of 25 years as the gold standard. Ibrahima addressed this with transparency, publishing 5-year field performance reports that showed efficiency only dropped by a marginal 4.2%, well within acceptable limits for most rural needs. Moreover, panels were designed for modular repair, so broken components could be melted down and reformed on site, keeping them in circulation rather than in landfills. The circularity of the system impressed environmental watchdog groups, who began including Desertec in their lists of regenerative technologies. In a surprise announcement, an ecotech fund based in Norway pledged $5 million in grants and technical support to scale the initiative. This allowed Ibrahima to open 2 new hubs, one in Sudan and another in northern Nigeria, both built by local labor and equipped with satellite-linked training modules. Each hub became a beacon of possibility in regions long dismissed as too unstable or remote for innovation. Meanwhile, a shift began occurring in global conversations about renewable energy. No longer was Africa only portrayed as a beneficiary of green aid. It was now being recognized as an incubator of green ingenuity. At the 2026 Global Energy Summit in Berlin, Ibrahima shared the stage with CEOs of solar conglomerates and was lauded for reshaping how solar material sourcing could work. He presented new research showing that different sand types across Africa had unique properties, some even superior to traditional quartz sources. From the Sahara to the Kalahari, local geological surveys were conducted to identify viable sand for community-driven solar fabrication. This knowledge birthed a project called Map My Sand, a crowdsourced platform where geotagged samples and lab results were uploaded in real time. Students and amateur geologists across the continent participated, mapping sand potential the way others might map oil or rare earth minerals. The open access database became a hotbed for collaboration, with researchers from Brazil, India, and Indonesia reaching out to adapt the system in their own desert zones. Back in Mali, the original prototype panel still sat on the roof of Ibrahima's family home, now powering a smart irrigation pump for their rooftop vegetable garden. He often referenced it during interviews, not for nostalgia, but to emphasize that transformative solutions often begin from the most modest materials. Meanwhile, partnerships with African universities led to the establishment of degree programs focused solely on regenerative solar technologies. Curricula blended material science, indigenous knowledge systems, and field-based solar construction, creating a new kind of engineer, one who could design as well as build on-site. At a graduation ceremony in Senegal, Ibrahima handed out diplomas, reminding students that their power lay not just in what they knew, but in what they could teach others. As the Desertec movement grew, resistance from legacy power providers increased. Utility companies lobbied governments to impose regulations on informal solar grids, fearing loss of market control. Some communities faced fines for unregistered microgrids, while others had panels confiscated under claims of noncompliance. This sparked a wave of advocacy, with Ibrahima joining forces with African legal scholars to draft model legislation for renewable microinfrastructure. Their proposal emphasized the rights of off-grid communities to self-generate clean energy and called for government support rather than suppression. A continent-wide petition gained over 2 million signatures in a matter of weeks, forcing policy discussions in several parliaments. By 2028, Mali became the first country to officially recognize Desertec-built microgrids as a legal energy entity, protected by law and eligible for subsidies. Other nations followed, creating a ripple effect that fundamentally reshaped Africa's energy policy landscape. This legal shift also encouraged innovation from unlikely sectors. Fashion designers began embedding thin Desertec layers into fabric to create solar-charging garments. In Uganda, a startup developed foldable Desertec umbrellas that charged phones while shading market stalls. In Niger, solar-lit sand bricks replaced kerosene lamps in community street lighting, reducing fire hazards and improving nighttime safety. Even cultural institutions got involved, with museums in Morocco displaying Desertec panels as artifacts of contemporary African innovation. Ibrahima was invited to deliver lectures at MIT, Oxford, and the Tokyo Institute of Technology, but he insisted on keeping his base of operations in West Africa. To him, remaining grounded was not just symbolic, it was strategic. He believed that the proximity to those most affected by energy poverty was essential to maintaining relevance and accountability. In 2029, a sudden surge in global energy prices led to widespread blackouts across Europe and Asia. Amidst the chaos, Desertec-powered communities in Africa remained lit and functional, sparking a wave of international media coverage. Documentaries, news features, and podcasts began asking the same question: how did Africa beat the blackout? The answer pointed to a decentralized, community-driven, and resource-based energy strategy, one pioneered by an inventor who had once lacked access to light himself. Ibrahima, now in his early 40s, reflected on this shift with humility. He had not set out to change the world, only to answer a childhood question rooted in the heat of the desert. And yet, by turning sand into solar, he had created a blueprint for a new global energy paradigm. It wasn't just about technology, it was about trust, empowerment, and rethinking what value truly meant. By the end of the decade, the phrase desert power entered common use not as a fantasy, but as a reality grounded in local innovation. Millions of households were lit by panels that carried no brand name, just the quiet mark of their makers and the knowledge they carried. A continent often spoken of in terms of deficits now became the world's teacher in energy abundance. And as the sun continued to rise over the dunes of Mali, it powered more than homes. It powered hope. Hope that solutions could come from within. Hope that Africa's future wasn't written in scarcity, but in sand. Hope that even the forgotten could build the unforgettable. And all of it began with a boy, a question, and the burning heat of a desert that refused to be wasted.